Mice pie. Mice never tasted so delicious.
Today we're going to talk about the logic behind poker hand ranking. Why are they ranked this way? In a poker game, they are ranked as follows. The best poker hand is, well, a royal flush, followed by a straight flush, and then four of a kind, full house, flush, straight, three of a kind, two pairs, one pair, and then finally high card. This ranking system is accepted by many different poker games. Now, why are they ranked this way? What is the logic behind this ranking? Well, here we go. The harder to get, the higher the rank is. Now, the question here. Can you find out what are the probabilities for these different types of poker hands? Royal flush, straight flush, four of a kind, full house, and so on. What are the probabilities to get these types of poker hands? Pause the video if you want to give it a try. Please like this video and subscribe our channel to get more interesting math problems. Now let's talk about the solution. Before we go to the details, let's just give a brief introduction of our standard deck of poker playing cards. In a standard deck, there are four suits: club, diamond, heart, and spade. Well, in each suit, there are 13 cards. And in total, we're going to have 52 cards in a standard deck. Now, for a poker game, for this poker hand, we make the following assumptions. Firstly, the deck of cards are well shuffled. Secondly, 5 cards are randomly selected from the deck without replacement to form a poker hand. It's a 5-card poker hand. Under these assumptions, all the possible poker hands are equally likely to occur. Now, if we let M be the total number of possible poker hands of 5 cards, let N of A be the number of possible poker hands of a certain type. For instance, we say flush. Then the probability to get this type of poker hand is gonna be probability of A equals the number of possible poker hands of this type A over the total number of possible poker hands M. So probability of A equals N of A over M. Now, based on this formula, to find the probability of each type of poker hands, we only need to find out the following numbers. Now, firstly is the total number M of possible poker hands of 5 cards. Second, the number of possible poker hands in each type. That is to say, well, the number of different poker hands of royal flush, as denoted as N1. The number of different poker hands of straight flush, denoted by N2. And number of different poker hands of flush, 4 of a kind, denoted by N3, and etc. then the probability of getting a certain type I of poker hands is simply the probability for the S type equals Ni over M. Now if we can find these numbers M and Ni, then all these probabilities can be found, and we can compare their probabilities, and then we will understand why the poker hands are ranked this way. Now, let's firstly talk about the total number M of different possible poker hands of 5 cards. How to find M? Now, as we know, there are 52 different cards in total. We want to select a 5-card poker hands randomly selected without replacement. Now, another thing we want to mention here is the order of these 5 chosen cards in a poker hand does not matter, right? So you have these 5 cards. No matter how they are ordered one after another, it doesn't matter, right? So you have these 5 cards, the order doesn't matter. Now, therefore, we can easily see this is the number of combinations of 52 cards taken 5 at a time. Now, which is given here, 52 choose 5 equals 52 factorial over 52 minus 5 in the parentheses factorial times 5 factorial. And then you can calculate, this is given here. We can easily find this number using a calculator. Now here M is given here, right, equals, this is given here, right? It's a very pretty large number. Now, next, let's try to find how many possible royal flushes are there. The number N1. Now, in order to be a royal flush, now it must be a flush. They must be of the same suit. Secondly, it must be a straight consisting of 10, Jack, Queen, King, and Ace. So there is only one royal flush in each of the 4 suits. So therefore, in total, we only have 4 possible royal flushes. So therefore, N1 is simply 4. That's the number of possible royal flushes we can get. Now, secondly, let's see, what about the number of straight flushes? The number N2. Now, in order to be a straight flush, here, you have to be a flush. They must be of the same suit. Second, a straight. It must be a straight other than the set of cards 10, Jack, Queen, King, and Ace, which is a royal flush. So it is a straight, but not royal flush. Now, they can be, for instance, they can be Ace, 2, 3, 4, 5, 2, 3, 4, 5, 6, and finally 9, 10, Jack, Queen, and a King. So these are all straight flush. So as you can see, in each suit, there are 9 straight flushes. So in total, we have 9 by 4, which is 36 straight flushes. Therefore, it's simple, N2 is just 36. Let's consider the 4 of a kind. How many such poker hands? This N3. In order to get a 4 of a kind, we have to have, firstly, 4 of one kind. For instance, 4 kings. Now plus 1 of another kind. Now for instance, we have 1 4. So 4 kings and 1 4 put together, that is 4 of a kind. Now how to get this 4 of a kind? Let's consider the following steps. First, choose the first kind. All right, so there are 13 different kinds of cards, so 13 choose 1, that's 13 possible ways to do this. Step 2, because we have 4 of a kind, let's just choose 4 cards from this kind, all of them. That's 4 choose 4, okay, equals 1. This is step 2. Now we need one of another kind, so let's firstly choose another kind, which after the first kind, we only have 12 other kinds remaining. So 12 choose 1, that's 12. And in this selected kind, we just need to choose 1 card from this second kind. So in this second kind, there are 4 cards. We choose 1 of them. So 4 choose 1. That's 4 possible ways. Now, after these 4 steps, we got for a poker hand 4 of a kind. So by multiplication rule, we have N3 equals, all right, 13 choose 1 times 4 choose 4 times 12 choose 1 times 4 choose 1. That is 13 times 1 times 12 times 4, which is 624. That is N3, the number of possible 4 of a kind. Now let's try to find the number N4, the number of possible full houses. So in order to be a full house, there must be 3 of one kind, for instance, 3 kings, and 2 of another kind, say 2 fours. So 3 kings plus 2 fours put together, that is a full house. Now let's view this one as several steps. First, step 1, we want to choose our first kind. Now there are 13 different kinds, so 13 choose 1. That's 13 possible ways for step 1. Step 2, we're going to choose 3 cards from this kind. So 4 choose 3, that's 4 possible ways. So after step 1 and 2, we got 3 of one kind. Then we're going to do 2 of another kind. Firstly, let's choose another kind from the remaining 12 of them. So let's see, 12 choose 1, which is 12 possible ways. And then from this chosen kind, we choose 2 of them. So which is 4 choose 2, that's 6. Now after step 1, 2, 3, 4, we got 3 of one kind, 2 of another kind. That is a full house. How many ways are there to get a full house? Well, by multiplication rule, we have N4 equals 13 choose 1 times 4 choose 3 times 12 choose 1 times 4 choose 2, which is 3,744. That's the possible number of full houses out there. All right, let's now talk about the number of possible flushes, N5. In order to be a flush, we need all these 5 cars are from the same suit. And not just that, they cannot be a royal flush. This is we're talking about here is normal general flush, not royal flushes and what? Not straight flushes. All right, they're not royal flushes, not straight flushes. Now let's see how can we get a general flush. Step 1, let's choose the suit. Right. There are 4 suits in a deck, so 4 choose 1. There are 4 possible ways to choose a suit. Now step 2, we're going to choose from this chosen suit, we're going to choose 5 cards. Now 13 choose 5. Oh, that's 1287. But be careful. Now within these 5 cards, they may be royal flush, maybe straight. Now we got to subtract those cases. So by multiplication rule, there are 4 choose 1, 13 choose times 13 choose 5, which is 51, 48 flushes. Well, be careful. These flushes includes the royal flushes and straight flushes. So in order to get the number of general flushes, we have to subtract the number of royal flushes, the number of straight flushes from 5148. So that is N5 equals 5148 minus N1 minus N2, which is 5108. That's the number of flushes we're talking about here. All right, be careful. We got to subtract the number of royal flushes and the number of straight flushes from 5148. Next, we are going to talk about my streets, right? How many possible streets are there? N6. Now, in order to be a straight, again, it must be a straight, right? So that is to say, it must be from ace to 3, 4, 5 to 3, 4, 5, 6, and so on, and 10, jack, queen, king, and ace. So that's a straight. But this straight do not include the royal flush and straight flush. You got to subtract that as well. Now it's not a royal flush and not a straight flush. Okay, so again we got to subtract those cases. Now how to get a straight? Step 1, choose a starting kind. Now as you can see, we have from ace to 5, 2 to 6, 10 to ace. All right, so there are 10 starting kind. So ace, 2, 3 till 10. So we choose a starting kind. It must be either ace, 2, 3, or finally 10. So there are 10 possible ways to choose a starting kind. Now, once the starting kind is chosen, well, this straight is fixed. So next, we're going to choose one card from the starting kind. Okay, so choose one card from the starting kind. That's 4, choose 1. That's 4 possible ways. And similarly, we're going to choose one card from each of the following kinds. So for each of them is 4 choose 1. So 4 choose 1 to the power 4. That's 256 possible ways. Then after step 1, 2, 3, we got all the streets. So by multiplication rule, we have 10,240 streets. Well, be careful here. These streets includes royal flushes and street flushes. All right, be careful. We got to subtract those numbers from the total. Now, therefore, we have N6 equals 10,240 minus N1 minus N2. That is 10,200. That is the number of streets, possible streets here. All right, next is the three of a kinds. Three of a kind, all right, number N7. How to find the number N7? In order to be three of a kind, we have to be careful. Firstly, we have three of one kind. For instance, we have 3 kings. We need to have one of another kind. For instance, 1, 4. And finally, one of the remaining kinds. Okay, so it cannot be the same as the first kind or the second kind. It must be one of the remaining kinds. So for instance, 1, 7. Now, 3 kings plus 1, 4 plus 1, 7, you put them together, that is 3 of a kind. How many are there? All right, step 1, similarly. All right, so we're going to choose our first kind for these 3 cards. Now, choose the first kind. 13, choose 1. That's 13 possible ways. Second, we are going to choose 3 cards from this kind. That's 4, choose 3. That's 4 possible ways. Step 3, we are going to choose, be careful here, we're going to choose 2 kinds from the remaining ones. All right, so after the first kind, there are 12 kinds left. So we choose 2 of them. So here is a combination number of combinations. 12 choose 2, which is 66 possible ways. Now here, because we have one, they are both have 1 cards, so the order doesn't matter. So that's why we are using these combinations. 12 choose 2, 66. Step 4, we choose 1 card from each of these 2 kinds in step 3. So that's 4 choose 1 raised to power 2. That's 16 possible ways. Now, by multiplication rule, we got, all right, so our N7 equals 13 choose 1 times 4 choose 3 times 12 choose 2 times 4 choose 1 raised to power 2. So which gives us 54,912. Okay, that is, there are 54,912 possible poker hands which are 3 of a kind. Next, how about 2 pairs? How many poker hands that are 2 pairs? Okay, in order to be a poker hand that is a 2 pair, contains 2 pairs, we need 2 of one kind, for instance 2 kings, and 2 of another kind, for instance 2 fours, and plus 1 of the remaining kinds. So for instance, 1-4. So 2 kings, 2 fours, plus 1-7, that is a poker hand that is contains 2 pairs. So that's 2 pairs. Now, step 1, we choose 2 kinds for the 2 pairs. Now, 13, choose 2. 78 possible ways. Second, we're going to choose 2 cards from each of these 2 kinds in step 1. That's a 4 choose 2 in the raised to the power 2, so that's what? 36 possible ways. Step 3. We're going to choose 1 kind from the remaining ones, so there are, after choosing 2 kinds, there are 11 kinds left. So from this 11 we choose 1, so 11 choose 1, that's 11 possible ways. And from this kind in step 3, we just need to choose 1 card. All right, that's 4 choose 1, which is 4 possible ways. Now, after these 4 steps, we got a 2 pair. So by multiplication rule, we see that N8 equals what? Okay, 13 choose 2 times 4 choose 2 square times 11 choose 1 times 4 choose 1 equals 123,552. That's the number of possible poker hands which are 2 pairs. Next, the number N9, just 1 pair. Okay, for a poker hand to be 1 pair, so we firstly have 2 of 1 kind, and then 3 cards of different kinds from the remaining kinds. Say 1 jack, 1 4, and 1 7. So 2 kings plus 1 jack plus 1 4 plus 1 7 together forms a poker hand that is 1 pair. Now, how to do that? Step 1, we choose 1 kind for the pair. So 13 choose 1, that's 13 possible ways. Step 2, we choose 2 cards from the kind in step 1, that's 4 choose 2, 6 possible ways. So after step 1 and 2, we got 2 of 1 kind. Now step 3, we're going to choose 3 kinds for these 3 cards. Okay, so that's after the first kind for the pair, then there are 12 kinds remaining, so 12 choose 3, that's 220 possible ways. Now because for these 3 kinds, in each of these 3 kinds chosen in step 3, we choose what? 1 card. Okay, so step 4, we choose 1 card from each of these 3 kinds in step 3. So 4 choose 1 raised to power 3, that's 64 possible ways. Now after step 1, 2, 3, and 4, we got a poker hand that is 1 pair. So how many ways are there? By multiplication rule, then this one equals a 9 and equals what? 13 choose 1 times 4 choose 2 times 12 choose 3 times 4 choose 1 raised to the power 3. That is 1,098,240. That's the number of poker hands which are 1 pair. Well, this is a 9. Finally, next is our high card. All right, this is is not all the other cards. All right, all the other poker hands. It's not a royal, not a royal flush, not a straight flush, not a full house, not a front. Well, it's all the remaining poker hands. So how to get the number in 10? So it is not any of the above types. How to do that? We know that the total number is m equals 2,598,960. These are the total number of different poker hands. So we subtract the sum of n1, n2 till n9 from this total. Then that's going to be n10, the number of high cards. So n10 equals m minus the summation of n1, n2 till n9. So plugging all these values, we got n10 equals 1,302,540. That's the number of possible poker hands which are high cards. Well, let's now give a summary of this video. We have found the total number of poker hands m, the number of royal flushes n1, for straight flush n2, 4 of a kind n3, full house n4, flush n5, straight n6, 3 of a kind n7, 2 pairs n8, 1 pair n9, and finally high card n10. We can see that these numbers n1, n2 till n10, they are in the increasing order. So that is to say, the chance are getting what? Higher and higher. From royal flush, straight flush, and then finally to high card. Which means it's getting easier and easier in this order. So that is why the royal flush beat straight flush, and straight flush beat 4 of a kind, 4 of a kind beat full house, and so on. So if we want to find the probability of a certain type, we can simply taking this ratio. For instance, the probability of getting a full house now is probability of getting a full house equals the number of whole full houses n4 over the total number of poker hands m. So as we can see, it's 0.00144056762. It's a pretty low number, pretty low probability. So that's why full house is really relatively high, ranked relatively high there. Well, that summarizes the video, and I hope you found this video helpful. Thanks for watching. Please subscribe our channel, and have a wonderful day. I will see you in the next episode.